Yep. I type in instance type instead of ID. Interesting. So this ID, you can think of it almost like a generic. It's a pointer to an instance of any class. So this is saying that our init is going to return an instance of some class. This is actually not specific. ID is different than instance type. Instance type is saying we're specifically returning a carnival barker, as opposed to ID is a pointer to an instance of a class. And let's see why ID and instance type are not the same when we fight with inheritance on Monday. We're going to fight with inheritance. It's going to be tough. On Tuesday, let's say. But they're actually not the same thing. So might be slightly more proper to use instance type. Jason, you went against something that I really loved, and I actually loved you going against it. You moved this inside. Why'd you do that? How'd you do that? So I had it as a global var. Is this global or where is its context? Yeah. Okay. What we'll also talk about when we talk about inheritance is why I might actually want this to be global. I can have a static var here, but there are certain places it's not going to be able to be used. There are certain contexts we're not going to be able to use it. But let's use it for now. It looks nice. I like it. Let's see what happens. I'm going to save this. I'm going to save this. Important question here. Where does this init function come from? Right now, where does it come from? Why is that? But we just implemented an init function. Why doesn't it use that? It's slightly more structural. Why isn't this init function being used? Does main.m use the implementation of Carnival Barker, or what does it know about Carnival Barker?
Right now, main.m is importing to the header file. We haven't indicated the init function in our header file.
Yep. We haven't added the init to our header file, so there's no interface function for our Carnival Barker in the interface. The init it's looking at is what's inherited from NSObject, because we haven't said there is type, there is an instance method called init here. Now that we've said that, Sam, let's go back to this oop word. What principle of object-oriented programming is this an example of? Yeah, so we have an init that we got from NSObject, but we just defined our own init. It's something to do with how subclasses and superclasses work. Yeah, children can behave differently than their parents, which is called polymorphism. Hey Jack, what are the two common types of polymorphism? And what is this an example of? So I inherit an init from NSObject, but I also define my own. Yeah. Here we override NSObject's init, and when we use this interface, we'll be calling the init to find for a carnival bark. Tuesday. Can you create custom dinits? Yeah. If you inherit something, you can override it. What? Amazing. Yes, I agree. Cool. Okay, so here we go. Got a carnival barker. When I create one, it increases the number of remaining barkers, which I have right now as a static int on number of remaining barkers. Here, now within my main function, this alloc I get from NSObject, but this init is the overridden carnival barker init method. Why is init an instance method? Angela, on line 34, I send two messages. First, I send the alloc to the class type carnival barker, but then I say init is actually an instance method. How does that work? Okay. Well, I'm doing two things, right? I'm sending two messages. That's why I see two square bracket openings, and then eventually a close and a close. Which means that I'm actually kind of being lazy. I'm doing two things in one line. Dang. What I could be doing is first allocating the space, then calling the actual init function. So this whole construct right here, this expression, class carnival barker alloc, creates the instance of a carnival barker. And that means that our init, what that does is it provides all of what's defined in the init function. So whatever we implement, which is everything from its superclass, and then increasing the number of barkers, that's acting on this already existing instance of a carnival barker. We're used to init meaning let's create a new object. That's not actually what's going on here. The second I create my pointer to a specific place in memory, I say that I have an instance. So init is no longer the specific thing that creates for us an instance. Instead, it's just a particular way of giving values to an instance. Hang on 1 second. Instance is created when we make a pointer. Sunny?
I tried in the same line to also send a message for it to bark.
Mm-hmm.
And the error I got was that the bark returns void and it can't be applied to a pointer.
Yep.
Can you explain?
Yeah, think about what's being declared on line 34.
Oh, the pointer to the barker.
Mm-hmm. We could do this, just like we might lazily. This whole thing returns void. But what it's doing is creating its own carnival barker, then initializing it with some stuff, and then calling bark. So we've never even made reference to the barker being created. Here, I want my barker so I can do a bunch of things with them.
But you did just then, you didn't create a pointer, you just created an instance of a carnival barker without a name or reference to it, right?
So I don't have a reference to where it is in memory. That's right. It's going to be allocated somewhere, but I won't know where.
You won't have access to it.
Mm-hmm. After that line. It's just like in Swift if I said UI view, that's a bad one, array dot shuffle. There's no reference to this array, I can't use it anywhere. Cool, got a barker, gonna make it bark. Let's see how many barkers are in our ecosystem. There's one. Thanks, Jason, we can make barkers. Should we make a whole bunch of them? Good barker, bad barker. We should de-initialize one at some point.
We have to deallocate space for in memory too, because otherwise we might, the reference count is either, right?
Say that again?
After we de-initialize an instance of a carnival barker, we also have to allocate space for it.
We can actually trust our de-initializer to do it for us for a specific reason. I think we'll talk about that with iOS development. Jason, there are 3 remaining barkers in our ecosystem. So that static var is working, huh? All right, let's go with it. What? It is better, but I'm actually going to find a better explanation for this next time, because I don't think it's sufficiently explained. Yeah.
The new keyword for the net is creating place of allocate and the net.
Is that a question or?
Because I know that it specifically looks for method copy and net.
Mm-hmm.
So if we change the name of the net method that we made in the implementation interface, it's gonna go super fast as default.
Yeah. Let's go look at that new method, because that's actually a really great point. So what Jason said was, in the past, we've seen when we create and init a new object, we could just send the message ns object new instead of alloc plus init messages at once. This still works, even with our init override. This might work, it might not. Init override. Question, why? 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 Do you know the clip I'm talking about? Can you find it for me, please? Why does this still work? Why does this still create a new Barker and increase our number of Barkers, which tells me that our override init is the one that's being called? Which tells us what about inheritance? And polymorphism and object-oriented programming. New is just looking for, like you said, allocate plus init. And since our Carnival Barkers override for init still named the same thing, the new method will use it. Let's go look at new. Objective-C Swift unavailable. All right, well, don't use it then. But new doesn't tell us enough. That's a shame. But it's just calling allocate and then init, and that init for a Carnival Barker, since this is going to look at its interface, it starts with the class and then looks back in its superclasses if it doesn't find what it's looking for. That is, again, the basic concept of which principle? Eric M. Which principle of object-oriented programming does this continue to tie into? Which specific one does this continue to apply to? Sorry? Oh, hell yes. Polymorphism. So polymorphism is going to start with our current class, not the base class, and look for what we're going to see in a second, properties or methods that are available at that level. If it doesn't find it, it's going to go back and back and back into the inheritance that it's gotten from base classes. You can have multiple inheritances, so it's going to look at it almost in a chain. Current class, its superclass, A's superclass B, and this chain could go on for a really long time. Looks first for methods, properties in current class A, so on and so forth. And that's how it gets and determines its functionality. New exists on its superclass, but since new is just substituting in the functionality for allocate and then init, it finds that init in this base class. Sunny?
Clarifying question, this, if we were to do this in Swift, would be an override init, and not creating multiple inits where you can choose between different inits, right?
Yes.
Could you also do the latter, even if they're all named the same? Because here we're not indicating anywhere that it's override, we're just having the same name.
Right. Writing multiple inits with different, forgot exactly how you phrased it, but that's the other type of polymorphism called method overload. So overriding is directly saying this works in a different way. Overload is having multiple ways of getting to the same end result. All right. Let's do one last thing. I think that if we were going to be nice to a carnival barker, our carnival barker to feel like a human being in what can be a trying job would at least like to have a name by which they can be referred to. Add this to their interface and implementation as a property. So let's take no more than 6 minutes. We'll make a quick property, and then we'll spend more and more time with our friend, the carnival barker, next week. Yeah, right? I don't know. Such a good question. Barker attempts to attract patrons to entertainment events by exhorting passing members of the public, announcing attractions of show. Step right up, right? That's their cry.
Oh, it's an actual thing.
Yeah.
I thought it was just like some dumb circus dog.
No. So a proper bark would be step right up.
That makes more sense.
Yeah.